Hello students, this is the second part of the lesson current electricity for the 10th standard. Right? In the previous lesson, you have learned the terms like potential difference, current and resistance. Now the next concept is about Ohm's law. Okay, now when you have two conductors and when they are being joined by a metal wire, you find electrons will flow from a conductor where there is high concentration of electron to a conductor where there is low concentration of electrons. Now this flow of electrons will not be a continuous process. Instead, this will go on till equilibrium is reached. Alright? Now, if you continuously maintain a potential between both the point, then you find current will flow continuously when you have one end at a higher potential and another end at a lower potential. Now, if Ohms was the one who studied that, who actually observed that when current is passed through a conductor, it was of certain resistance R when a potential difference of V was maintained between the two ends. It was observed that V, that is the potential that is applied, is proportional to the current. Potential difference is proportional to the current. Now, if I remove this proportionality sign, I can write it as V is equal to I times R, where R is the constant, where R is the resistance of the wire, I is the current, and V is the potential difference. So, this is nothing but Ohm's law. In the form of statement, how do you state it? That voltage or applied potential is directly proportional to the current. Correct? Now, using this, I am going to derive the unit of R, that is resistance. Now, in terms of R, I can write it as R is equal to V upon R. So, the unit of V is volts and unit of I is amps, that is A. I can write it as volt per amp. So, this volt per amp is nothing but ohms. Given as ohms, which is abbreviated using the Greek symbol omega. So, this is the unit of resistance, which is ohms. We don't write it as volts per amps. Instead, we write it as ohms using this as the symbol. Right? So, this was about Ohm's law. Now, I'm going to consider a wire. We'll see what are the conditions which are related to the resistance. How does resistance of a wire get affected? Now, it is being seen there are certain conditions which affects the resistance of the wire. Okay, before that, I will just give you a few examples. Now, this law, you will be doing an experiment related to this, which is called as Ohm's law experiment, which will be performed in the laboratory. Alright. Now, there are certain resistors which obeys Ohm's law. Such resistors are called ohmic resistors. And there are certain resistors which do not obey Ohm's law, which are called as non-ohmic resistors. Now, ohmic, if you plot a graph of V versus I, you get a straight line graph passing through the origin. Alright? So, you get a straight line graph which passes through the origin. So, you can, if you know you can find the slope using this graph, or you can, if you take current on the current on the x-axis and voltage on the y-axis, you find the Ohm's law for ohmic resistor. You are going to get a straight line with this, but if the resistors are non-ohmic, you don't get a straight line, instead you get a curve. Now, examples of ohmic resistors will be all the metals, because when current is passed at a particular temperature, now this Ohm's law is true for a particular temperature, but if the temperature increases, then you find Ohm's law will not hold true. Okay. And non-ohmic resistors are like junction diodes, LEDs. They do not transistors, they do not diode, they do not obey Ohm's law. So they are called as non-ohmic resistors. Right? Okay. Now we learn about the factors affecting resistance. What are the factors? Now the first factor is material of the wire that is being used. Material of the wire. Now, if you are using different types of wires, like if you are using different metals, so when you are comparing silver, in fact silver is the best conductor, it will have least possible value of resistance. If you are using insulators, it will have very high amount of resistance present. So if you check the order of resistivity, it will be least for silver, followed by aluminium, copper, and it goes on. So depending on the material that is used, accordingly the resistance will vary. The second factor is the length of the wire. Length of the wire. As the length of the wire increases, you find resistance of in the circuit also increases. So resistance is in fact directly proportional to the length of the wire that is being used. Correct? Because there are, if you look at from microscopic point of view, you find that as the length becomes longer, there will be in fact the electronic composition will be different. There will be more number of positive ions. So in fact with length resistance increases. The third factor is the area of or you can, for that matter, you can say thickness of the wire. If the wire is thick enough, that means it is having a larger area, then you find that the resistance will decrease, because electrons will get another. You find that as thickness of the wire or the conductor increases, you find resistance will decrease. Correct? And the next factor, the last factor, the fourth factor is the temperature of the as temperature of the conductor increases, you find resistance also will increase. Alright? So if you consider a hot bulb, a bulb which is glowing for a longer time, it becomes hot. So its resistance also will be more as compared to a bulb which is not glowing. It will have a low resistance path, because resistance depends on temperature as well. So these are the four factors. Now I'll just combine. If I write it in the form of an equation, I can write it as, now resistance is directly proportional to the length of the conductor. More the length, more will be the resistance. It is inversely proportional to the thickness. It is inversely proportional. That means it is inversely proportional to the area. More the area, less will be the resistance. Right? Less the area, more will be the resistance. So when I combine both these equations, I can write it as R is proportional to L over A, where L is the length and A is the area. Now I am going to introduce equality sign. So I can write it as R is equal to rho times L upon A. Now this is a constant for different conductors will have a different value. Now this rho is called as resistivity. Correct? So now I am going to write this equation in terms of rho. That is, this is called as resistivity, denoted by Greek alphabet rho. stands for rho. Now in terms of resistivity, I can write rho is equal to R times A upon L. Now I will come to the unit of resistivity. Okay, now I'm going to derive the unit for resistivity, or it is also called as specific resistance. Now unit of R is which is ohms. Resistance is given in terms of ohms. Now you have area. Now this can be written as R times pi R square upon L. Correct? Now R, where R is the radius. So unit of radius R square will be in terms of meter square upon length will be again in terms of meters. So I can cancel this and this. So I am going to get it as ohm meters. So unit of resistivity is ohm meter. Okay. Now I'll quickly tell you about the factors which affect the specific resistance or resistivity of the given conductor. Now resistivity of a given conductor, it depends, it is different for different substances. Now different conductors will have different value of resistivity. Correct? If it is metals will have low resistivity, and even alloys will have very low resistivity. And for insulators will have a very high value of resistivity. Correct? Next, I will be discussing about conductivity. Now, opposite or reciprocal of resistivity is what is called as conductivity. Conductivity, which is given by Greek alphabet sigma, so it is reciprocal of resistivity. So sigma is equal to 1 upon rho, which is again, so its unit will be per ohm per meter, which is also called as Siemens. Right? So this also a substance which has very high resistivity will have low conductivity, and a substance which is having low resistivity will have high conductivity. Like metals will have very high conductivity and non-metals will have very low conductivity. Correct? Next is about choice of material of a wire. Depending on the value of resistivity, accordingly the material is being chosen. Like if you want to use a material for transmission purpose in household circuits and all, you will choose a substance which will have low resistivity. So usually aluminium and copper is being preferred because it has got very low resistivity. Alright, so first one is you can say for power transmission. For power transmission, copper or aluminium is preferred. Of course, silver is the best conductor, but we cannot afford to use silver because it is highly expensive. Second is if you want to use for a fuse wire. Okay, fuse wire. Now, fuse wire, what are the conditions needed? What are the specifications needed for a fuse wire? It should have a low melting point. Alright, so usually it is an alloy of lead and tin which is used to make a fuse wire. Alright, third one is choice of material for heating for resistors. If you want to make resistors, now for resistors you use manganese or constantan. Manganese or constantan are the materials which are being used to make resistors or resistance wires. Whenever they are to be made, this is being used. Now, suppose it is the bulk filament. bulb filament. For a bulb filament, now the bulb will glow at a high temperature, so it should have a very high melting point. So bulb filament, usually tungsten is the one which is being used, should have a high melting point. Alright, and then towards the end, fifth one, if any heating material is to be used, like for example, for heaters, geysers. For heaters and geysers, the element that is being used is a nichrome wire, alright, because it should have very high resistance and it should not melt easily, alright, high melting point. It should have high melting point. So for heater and geyser, accordingly, these materials are being used. So this was regarding the choice of material. Now towards the end, I will be explaining about superconductors. Now, in fact, superconductors, like suppose you are able to decrease the temperature of a particular wire. So as you keep on decreasing the temperature, you find that the resistance will become very less, because resistance directly depends on the temperature. As the temperature increases, you find that the resistance also increases. So, as temperature increases, resistance also increases. But if it is possible to reduce the value of temperature, if any conductor can be kept very low, in very low temperature, then you will find that it is possible to have zero resistance. So in that case, when the resistance in a conductor becomes zero, you will find that particular material will become highly conducting. So such materials are called as superconductors. Now in fact, it is very difficult. Now there are certain substances like mercury, then you have niobium. At certain temperatures, they behave like superconductors. Alright, so at very low temperatures, they behave like superconductors. But in fact, to attain that low temperature, in fact, you under current conditions, it is very difficult. But in the future, if this concept of superconductors, if they at all they are successful, then the heating, especially as far as transmission lines are concerned, then this heating effect can be minimized, and without any wastage of power, large amount of current can be transferred from one place to another. Alright, so with this I am finishing with this part, that is about